All right, so here is my second video. What I'm going to be doing is I am in the announcements. So I even posted a video. It's called May the 4th. May the 4th be with you. Okay. Um, and so that goes through how to navigate everything. But now I'm going to go through these 4.8 classification of reactions Google slides. And that link will be right here. Okay, when we get to it. Okay, so I'm going to go ahead and, hamburgers. Open that up. Can't seem to open it. There we go. All right, then if you click up at the top, it'll send you right to the Google Slides, and this is how we classify reactions. I will go to present mode to make it full screen. All right. So the first slide is asking, what is a species? You might remember it as a thing that is from biology class. And while that is still pertinent and true, a species in chemistry is an element or a compound. So if we look at an example, we have Na, which is sodium, as a solid, plus Cl2, which is a gas, yields NaCl, which is a solid. All three of these are species, okay? So the state of matter is important when we are talking about it. So reactions will include indicators of state. What are the three states of matter? Solid, liquid, and gas. Okay. There's also aqueous solution, which means something that is sitting in water, but that's not as big of a deal. Okay. So there are different types of reactions. A synthesis reaction would be two small things, A plus B, combining together to make AB. Okay. So you got one small thing plus another small thing makes one big thing. Okay. A couple of examples. Solid sodium plus gaseous chlorine gives you sodium chloride, solid salt. Okay, so what you're going to look for is two or more reactants. Reactants are the left side of this arrow. Okay, one product. The product is the right side of the arrow. Decomposition reaction. The word decompose or decomposition means to break down. Okay, so it's the opposite of synthesis. So we have something big, AB yields A plus B. So you have a bigger thing that's broken down into two or more smaller things. So let's say we have H2O, liquid water, and it is broken down into hydrogen gas, H2, and oxygen gas, O2. So what you're looking for is one reactant, which would be whatever's on the left side of the arrow, and two or more products, which is the right side of the arrow. Okay. Single displacement. That means one single thing is going to be displaced or moved for another. Okay. So if we have AB plus C yields AC plus B, what switched? Well, it was the B and the C. If we look at our chemical equation example, we have Mg plus HCl, HCl, AQ, yields MgCl plus H2. And if we look, what switched? It was Mg and H. Oop. The thing to look for is the element plus the compound yields the element plus a compound. Okay, but usually there's just one thing that's switching. All right, a double displacement means that two things are switching. All right, so if we have AB plus CD, we're going to switch A, and it's going to go with D. So it yields CB plus AD. So both things are switching. It would be like if you're at a dance, you got a date, somebody else that you know is at the dance, they also have the date, and you guys switch dancing partners at the same time. Okay. The example would be AgNO3 plus NaCl. So notice that yields NaNO3 plus AgCl. So Ag went and switched and joined up with Cl, and Na joined up with NO3 to create NaNO3. So it's a double switch. Okay. The thing to look for is that all species are compounds. What does it mean if something is a compound? Multiple capital letters. Again, if there are multiple capital letters, it is a compound. A precipitation reaction. No, I'm not talking about the rain, although it is kind of the same idea. Basically, what you have is a double displacement reaction. So notice there's multiple capital letters here. Okay, so PB, P is capital, N and O are capital, K and I are capital. In the PBI, P and I are capital. All these are capital. The big thing that's important when we said you have to look at the state of matter is if there is a solid. Okay, so notice the arrow is pointing to that. You need to look for a solid on the product side, but not the reactant side. And this is on a double displacement reaction. Okay, an acid-base reaction. You guys can do this one really easily in your kitchen. All right, so if you have an acid plus a base, you're going to end up with a water plus a salt. So if you were to do baking soda and vinegar, that is an acid-base reaction, a neutralization reaction. So we have HCl, AQ, which this is your acid, hydrochloric acid, plus sodium hydroxide, NaOH, this is your base. So acid plus base creates H2O, which is water, plus salt, which in this case is NaCl, table salt. Okay, but salts can be a lot of different things in chemistry, not just table salt that we put on our food. Okay, so formulas that start with H are acids. So anything that starts with H is acidic. Formulas that end with OH are bases, meaning they don't have a lot of H in them, and so they are basic. It would be something like toilet bowl cleaner. Okay, water is a product. It took off on me. Yeah, so water has to be a product. All right, a redox. Okay, it involves the transfer of electrons. All right, we've talked about electrons at length for a long time before we ever left. So if we had Mg, Mg would be plus 2, O would be minus 2, and it cancels out. Okay. So what we're doing is just what we did when we did the ion dating game. Plus 2 and minus 2, the numbers cancel out to equal 0. So we are good. Okay. You want to look for a single element species anywhere in the equation. If there's a single element species, it is a redox. Okay. Combustion reaction. So anytime you burn anything, and it can happen in a million different ways, you have combustion. And the big thing that you want to look for is you need oxygen over here on the reactant side, and then you're going to have carbon dioxide and water as products. Best place to see this is start your parents' car or your car, okay, and look out the tailpipe. you're going to see water dripping from it, and you're also going to see some exhaust. Okay. Your engine uses oxygen and mixes it with the gasoline that you put in the gas tank to create a big explosion that makes your pistons move and your car run. Vroom, vroom. Okay. So all reactions fit one of these categories, and most reactions fit more than one. I'll explain that more as we get to it. I'm not going to go through the examples at this point. We're going to end the video there. Have a good one.